Rigid body. Control of an object's position through physics simulation. Adding a rigid body component to an object will put its motion under the control of Unity's physics engine. Even without adding any code, a rigid body object will be pulled downward by gravity and will react to collisions with incoming objects if the right collider component is also present. The rigid body also has a scripting API that lets you apply forces to the object and control it in a physically realistic way. For example, a car's behavior can be specified in terms of the forces applied by the wheels. Given this information, the physics engine can handle most other aspects of the car's motion, so it will accelerate realistically and respond correctly to cal. In a script, the fixed update function is recommended as the place to apply forces and change rigid body settings, as opposed to update, which is used for most other frame update tasks. The reason for this is that physics updates are carried out in measured time steps that don't coincide with the frame update. Fixed update is called immediately before each physics update, and so any changes made there will be processed directly. A common problem when starting out with rigid bodies is that the game physics appears to run in slow motion. This is actually due to the scale used for your models. The default gravity settings assume that one world unit corresponds to 1 meter of distance. With non-physical games, it doesn't make much difference if your models are all 100 units long, but when using physics, they will be treated as very large objects. If a large scale is used for objects that are supposed to be small, they will appear to fall very slowly. The physics engine thinks they are very large objects falling over very large distances. With this in mind, be sure to keep your objects more or less at their scale. In real life, so a car should be about 4 units equals 4 meters, for example. Properties. Angular drag. The angular drag of the object. Angular velocity. The angular velocity vector of the rigid body measured in radians per second. Center of mass. The center of mass relative to the transform's origin. Collision detection mode. The rigid body's collision detection mode. Constraints. Controls which degrees of freedom are allowed for the simulation of this rigid body. Detect collisions. Should collision detection be enabled? By default always enabled. Drag. The drag of the object. Freeze rotation. Controls whether physics will change the rotation of the object. Inertia tensor. The diagonal inertia tensor of mass relative to the center of mass. Inertia tensor rotation. The rotation of the inertia tensor. Interpolation. Interpolation allows you to smooth out the effect of running physics at a fixed frame rate. Is kinematic. Controls whether physics affects the rigid body. Massachusetts. The mass of the RIGIDB. Max angular velocity. The maximum angular velocity of the rigid body measured in radians per second. Default 7, range 0, infinity. Max depenetration velocity. Maximum velocity of a rigid body when moving out of penetrating state. Position. The position of the rigid body. Rotation. The rotation of the rigid body. Sleep threshold. The mass normalized energy threshold, below which objects start going to sleep. Solver iterations. The solver iterations determines how accurately rigid body joints and collision contacts are resolved. Overrides physics. Default solver iterations must be positive. Solver velocity iterations. The solver velocity iterations affects how accurately rigid body joints and collision contacts are resolved. Overrides physics. Default solver velocity iterations must be positive. Use gravity. Controls whether gravity affects this rigid body. Velocity. The velocity vector of the rigid body. It represents the rate of change of rigid body position. World center of mass. The center of mass of the rigid body in world space, read only. Public methods. Add explosion force. Applies a force to a rigid body that simulates explosion effects. Add force. Adds a force to the rigid body. Add force at position. Applies force at position. As a result, this will apply a torque and force on the object. Add relative force. Adds a force to the rigid body relative to its coordinate system. Add relative torque. Adds a torque to the rigid body relative to its coordinate system. Add torque. Adds a torque to the rigid body. Closest point on bounds the closest point to the bounding blocks of the attached colliders. Get point velocity. The velocity of the rigid body at the point world point in global space. Get relative point velocity. The velocity relative to the rigid body at the point relative point. Is sleeping. Is the rigid body sleeping? Move position moves the kinematic rigid body towards position. Move rotation. Rotates the rigid body to rotation. Reset center of mass. Reset the center of mass of the rigid body. Reset inertia tensor. Reset the inertia tensor value and rotation. Set density. Sets the mass based on the attached colliders assuming a constant density. Sleep. Forces a rigid body to sleep at least one frame. Sweep test. Tests if a rigid body would collide with anything, if it was moved through the scene. Sweep test all. Like rigid body. Sweep test, but returns all its. Wake up. Forces a rigid body to wake up. Messages. On collision enter. On collision enter is called when this collider/rigid body has begun touching another rigid body collider. On collision exit. On collision exit is called when this collider rigid body has stopped touching another rigid body collider. On collision stay. On collision stay is called once per frame for every collider or rigid body that touches another collider or rigid body. Inherited members. Properties. Game object. The game object this component is attached to. A component is always attached to a game object. Tag. The tag of this game object. Transform. The transform attached to this game object. Hide flags. Should the object be hidden, saved with the scene or modifiable by the user? Name. The name of the object. Public methods. Broadcast message. Calls the method name on every mono behavior in this game object or any of its children. Compare tag. Is this game object tagged with tag? Get component. Returns the component of type if the game object has one attached, null if it doesn't. Will also return disabled components. Get component in children. Returns the component of type in the game object or any of its children using depth-first search. Get component in parent. Returns the component of type in the game object or any of its parents. Get components. Returns all components of type in the game object. Get components in children. Returns all components of type in the game object or any of its children. Works recursively. Get components in parent. Returns all components of type in the game object or any of its parents. Send message. Calls the method name on every mono behavior in this game object. Send message upwards. Calls the method name on every mono behavior in this game object and on every ancestor of the behavior. Try get component. Gets the component of the specified type, if it exists. Get instance id. Gets the instance ID of the object. To string. Returns the name of the object. Static methods. Destroy. Removes a game object, component or asset. Destroy immediate. Destroys the object obj immediately. You are strongly recommended to use destroy instead. Don't destroy on load. Do not destroy the target object when loading a new scene. Find object of type. Returns the first active loaded object of type. Find objects of type. Gets a list of all loaded objects of type. Instantiate. Clones the object original and returns the clone. Operators. Bool. Does the object exist? Operator. Equals. Compares if two objects refer to a different object. Operator. Compares two object references to see if they refer to the same object.